So while we have means and we can use those as our measure of center, we can also use medians. And oftentimes when in media or in research we refer to average, a lot of the times we actually are referring to a median. So first, an overview. We have our data set, the same one as the last video, where we have the number of collisions recorded in a given month at a specific intersection. And we have 20 data values, okay? So the median, so there's a few different ways to think about it. So a median is the middle of the data set which is intuitive, but okay, what does middle mean? More precisely, we can say that no more than half of the data values are greater than the median. So if you think about it this way, and it depends on what your sample size is. So if it's odd or if it's even. So we have two rules. So if your sample size is odd, the median is the middle number. So arranging your data values from least to greatest, the median is the middle number. So if you have 3 data values, a very small data set. If you had 3 data values, your median would be the second number, right? If n is even, the median is the arithmetic mean of the middle two numbers. Or data values. When we say arithmetic mean, that's kind of like when we do class midpoints, which is to say the median would be, the first data value that you have, right? So plus the next one up divided by 2, okay? And the k there is really like, it indicates the middle two numbers or the first of the middle two numbers. So we have n equals 20, that's even. So that means, if we think about it this way, we split it in half, right? So the 10th and the 11th data values and we divide those by 2. Remember, your data has to be sorted in order to use the median. So that's 1 plus 1 divided by 2, well, that's 1. Beautiful. So our median is 1. In other words, if we think of median as average, that means the median, or the average number of collisions here is 1. And that's different from 1.85. Again, like with the mean, medians only work for quantitative data. So we can't take the median of a data set that is categorical. But we do have an advantage when we use the medians, which is that medians are resistant to extreme values. And that's because our medians don't care about all the individual data values, right? What do the zeros and the ones and the twos, what did all of those have to do with anything in our calculation of the median? What matters is that when we arrange all our data values, right, then the middle two or the middle numbers are the only ones that we're taking into account when we're calculating the center. So medians, in some sense, are more appropriate for a distribution of data. In particular, we want to use medians when our data sets are skewed. Okay? So, to clarify, let's go back to that example that we had in the chapter overview. So this is a slightly skewed data set. And for the sake of illustration, let's suppose that here's our mean. So X bar is here. But our median is somewhere here. So when our distribution is skewed, then the median is a better measure of center because it takes into account the skewness of the distribution. If these match or are pretty close to each other, then that's a good indication that your distribution is symmetric, and in which case you could use either one. And in that case, the median is actually a really good replacement or alternative to your mean. Another thing to note briefly before we move on is that medians are also a measure of relative standing because the medians divide the lower 50% and the upper 50% of your distribution, and we'll get to what that means more precisely later in these videos. But roughly what we mean is if you know where you are relative to the median, then you know you're either in the lower 50% of those data values or the upper 50% of those data values.